So I'm going to show you my biodiesel processor that I built. I have been making biodiesel now for about 5 or 6 years, and this is my latest version of my processor that I currently use to manufacture the bio that I use in my vehicles every day. I guess we'll start over here with the start of the process. This is, I've called this the primary tank. This is where I put my oil in to start the process. I usually go ahead and fill it up. It's about a 25-gallon unit, and if you fill it all the way up to this ridge, it's about 30 gallons or so. At the bottom of this vessel, I have 2 valves. I have one valve that drains all the way off of the very bottom of the tank. It'd be this valve right here, and this valve actually is hooked to a standpipe. And a standpipe, what I'm talking about, is just a PVC pipe that's hooked to this valve, and it sticks up through the oil, and it'll suck not off the very bottom, but a level somewhere, you know, right about here. So if you look in the vessel right now, there's the standpipe level. We're just a smidge above that right now, and the purpose of having the standpipe is so any of the heavies will sink all the way past, and so you're not sucking off the very bottom, but you can make sure not you know, get any water in there for sure, and any glycerin that might have been poured back in here. The only thing that I might get in here is you can see some cornmeal floating on the top, which we try to do our best to keep that out in the settling process. And then up here in the top, I'll go ahead and get that, which is, this fits in here just perfectly. It's a modified drain pan, and then so these work wonderful. It's an oscillating fan guard, and it keeps this screen off the very bottom, and so you can see all the debris that I've saved from going into the oil by having this screen here. And this is just simply window screen. Okay, so what I will do, and I'll try to describe the process as I'm describing my processor. I'll fill this all the way up to this line because the standpipe keeps this amount from going through. What I want is, I want 25 gallons of product. So, you know, I'm about 3 gallons here, so if I fill it up 3 gallons more, I'll be sure to get 25 gallons in there. That's basically why I do that. Okay, so this line coming off the standpipe comes into this manifold of pump number 1, and this is pump number 1 is wired to this light switch, and I felt that was a very good way of turning it on and off without having some breaker to throw or something like that. This is the output of, let me get that light, Jeff. This is the output of the pump, and as you can see, I've got some quick, well, not really quick disconnects, but disconnects right here and right here. And so let's say if that pump failed, or if something got in there and locked the pump up, I can disconnect it here and here, pull that out, pull the head off, clean it, or whatever I need to do. So anyway, the output of the pump, we'll talk about it first. It comes up here, and then it'll T, and then I can direct the output of the flow from pump number 1 either into the reactor, which is I believe this is a 50-gallon hot water heater, 55 gallons, or I can, that would be like this, and then I could close this, open this, and direct the flow into, this is my settling container. Continuing to talk about the processor, on the inlet side, again, this is the intake manifold of the pump. I have a line coming out, a tube coming out of the actual bottom of the processor. The hot water heater, what I did, which was unique to the system, and I researched and I found that people were happy with this. You can probably notice that this is upside down. The reason for that is, at the natural top, which is the bottom now of this hot water heater, it has a a curved surface. And so if I set it upside down with this curved top, it'll drain completely. If I used this port as the drain, conventionally it would be right side up. This surface is curved as well, but I'll always have some stuff at the very bottom, and so they said if you flip it upside down, you can always drain everything out. So I have done this. Obviously you can see it's here and it works good, and I actually would recommend doing this. So we've got some ports here. This is simply a vent, and if I ever have anything I need to pour back in here, I can do that. I got a funnel stuck in here. This I just leave open. This is to make sure you don't get any pressure built up in here. There are typically 2 heating elements in here, and this processor is wired for 220. So what I've done is we would call it the top element naturally. Here it's the bottom element. This is the one that I use. This element I have disconnected, and then behind these covers we have a thermostat, and it can be set. This temperature of this oil, I would like to see it, you know, as hot as 150, but sometimes the cholesterol, I'll call it, in these lines keeps this tube from getting as hot as the temperature of the oil. I would say that it would be better to have a temperature probe in here or a thermometer in here to actually monitor the temperature of the oil. I don't have a temperature probe. I simply go with my experience, and I hold this line, and if it's as hot as you can hold it for a while and let go, it's almost too hot to hang on to, it's hot enough to run. It's ready to go. Again, I run this off of 220, and I've got this wired behind the wall to a breaker in my breaker box. When I want to turn the heat on, I'll simply flip the 30 amp breaker that I have, and it'll start to heat up. Okay, back down to the intake manifold. These ball valves are large opening. There's a term, I forget what it is right now, but there are ball valves that have very small holes in them. And what I did is I had to research, I had to find a source of, I think they called them full flow ball valves or something like that. So, you know, a little research could help you out there. All of these are inlets. This, you know, is an inlet, but it is mainly used as a drain. So in case I need to drain something out, I have a little piece of hose here attached, and normally what I'll do is when the product, I need to get it out of the vessel, I can go ahead and drain that into a container. This is my, I think I would call that a siphoning hose. This is where I draw in the methoxide. I mix my methanol and lye in this container ahead of time. When it's completely mixed, I'll bring it over here, put it in this location, bring this hose and stick it in the vessel, open this valve, which is smaller, and then restrict this valve as flow is occurring. What that'll do is that'll create a restriction here, increasing the suction on this hose, and then draining my methoxide down into the gears and mixing, and then I can bring it up and I can put it back into the reactor. So close these out. I'll open this to suck the product into the reactor from the primary tank, and then at one point I think I thought that I needed another valve here. I don't know its purpose. It doesn't have one right now. I guess if there's another reason to put something in there, I may have thought that I wanted to be able to suck product out of the settling container, but then later on in the game I figured, well, I don't really need to do that, and so this valve serves no purpose right now. Okay, I believe that I've covered everything. You know, looking at it here, there's probably better ways to configure this, but this way works, and you know, obviously I want you guys to look at it and see if there's anything you could take from it and use whatever you need, you know, to do. I just want to spread the word, basically. Okay. So we've got that. These barrels that I have here, these are 55-gallon plastic containers. What I've done in the top is I've cut a hole in the top with the outline of a 5-gallon barrel. So basically you could slide a 5-gallon barrel in here and it could act as a lid. And so anyway, these are upside down as well. I don't know if you can particularly see that, but there's the top of the barrel. Here's the bottom of the barrel. So at the top, the natural top of the barrel, we would have two bungs, one fine thread, one coarse thread, and inside those two bungs we have a smaller threaded hole that I can thread pipe fittings in. So I have underneath here, I've got each one of these containers has a complete drain, which would be this is a standpipe drain. That standpipe about 4 inches tall up through here, and I've drilled a hole in the bottom of my platform, 2x4 framed plywood face platform. Each one of the standpipes has a T and a ball valve, so I can purge any contamination out of this. This is where I want the good stuff to come out into the input of pump number 2. So I could put a container under here, purge this out until it flows clear, and then close that. And then if I open this valve, then I can send product from the standpipe tube down into the intake side. This is a complete drain for my next barrel over. So when you're underneath here, sometimes it gets a little confusing as to which barrel you're actually manipulating, but over time you'll figure that out. Over here I have a complete drain for my barrel number 1, which is my settling barrel. After the biodiesel is manufactured, it gets pumped into the settling barrel, and after it settles overnight, then I drain the glycerin into a cubie off of the complete drain. And after I have drained the glycerin off, you want to come up here and I'll show this line. This is the line of the standpipe. So the standpipe will come up to about here. I'll drain the glycerin down well below the standpipe line, so when I do drain out of the standpipe, I'm sucking well above the glycerin layer, and there's no danger of any glycerin getting into the wash barrel, which would create more soap and more work. So try to drain that out as much as you can. Okay, so we got the settling barrel, or barrel number 1. The washing barrel is the next phase in the process. After you take the raw biodiesel in here, and it is just like it sounds, we put it in here, we put water in, agitate it, drain the water out, which will include lye, methanol, and soap. Any glycerin, any heavier than biodiesel contamination will all fall out to the bottom. This, again, I said is the complete drain. So I will stick a bucket underneath it here and then collect the soapy water and dispose of it in the correct manner. Coming back here, we can see the standpipe drain for the wash barrel. Again, I can purge this out, make sure that nothing I don't want to come out. I can dump it basically and then open the valve, sending it into the intake manifold of pump number 2. So this is pump number 2. This is the intake manifold. This would be an intake, but it is used as a drain, so I can drain these lines and keep the raw biodiesel out and hopefully keep these to last a few more years. I have an intake from the settling barrel. I have an intake for the washing barrel, and I have an intake for this third barrel, which is the drying barrel. Again, you can see a consistent purge here. You know, if I was to, if there was any contamination, I could drain that out and then make sure that anything that I fed into the intake manifold of pump number 2 would be clean. So this is the intake side, this is the output side. Coming out of the pump with pressure, I can open this valve, send the final product. This is what would go through here, through a filter, and then out into a vehicle or to a fuel tank. The other part of the output would go up through the platform, come up through, and then tee off, and then I can send the flow into the drying vessel. I can send flow into the washing vessel, but usually never both at the same time. the pipe coming into the washing vessel and the pipe coming into the settling vessel are just the end of a tube. There's nothing on the end. There's just thread somewhere about here. On the end of this tube coming into the drying vessel, I actually have a T, and that T, one goes over here, one goes over here. It's a simple T. It looks just like this. And the reason that I put that in there is it comes down, I want to shoot the biodiesel across the inside of this barrel, and then it'll kind of cascade down across here. It you know, smears it out and makes it thin and increases the surface area. Because it's nice and thin, I have a little fan here. If I turn it on and blow air across and help evaporate any moisture, and that's how we dry the biodiesel. So there are other methods of drying. This is the method that I use. It works for me. I just want to say that, you know, feel free to use anything I've got here, and obviously I would encourage you guys to try to adapt and make it even better. So that's pretty much, I think that's about all that I can think of to talk about right now. I'm sure as soon as I turn the camera off, we'll think of some other things. Maybe I'll talk about the platform real quick. When I was deciding to make something like this, I thought, you know, I'd like to get it up off the ground. I had my whole design with the two pumps, the two motors, and I thought, you know, it'd be nice to have these up off the ground, and that way I could get up under here without, you know, crawling on the floor and, you know, working at an uncomfortable height. So I built this platform. It's 2x4s, and I have framed this. So this is just a, you know, like a conventional wall framing with facing here. This is an 8-foot piece of plywood cut in half, so it's 2 foot by 8 foot. And then I just can't remember what these are. These are about this high. This is about how high they are. And another thing I guess I would say is that you're gonna get spills. So probably the thing to do would be to lay down newspaper or have plenty of oil dry around. I found this concrete, I have a scraper, about a once a year maintenance scraping will, you know, make sure it doesn't build up too terribly bad. And then newspapers can be used, saturated and thrown away. So that is realistically just about it. So after going through this, the pieces of the processor and a little bit of the process, I'll probably add another segment to this talking specifically about the manufacturing process. But